Lesson 8.4, Angle, Sum, and Difference. So we're going to talk today about trig identities. A trig identity is a trig equation that's always true. We often use those to solve trig and geo problems and to understand mathematical properties. So if we know certain key trig identities, this helps us remember and understand important mathematical principles and ultimately help us solve numerous math problems. So we will look at basically two identities. We call them the sum and difference of an angle identities. And there are technically four of them. And because we have a cosine and a sine for each one, there's two that revolve around the sum identity, and there's two that revolve around the difference identity. So just make sure that you remember that sum means addition, difference is subtraction, and then we have both a sine and a cosine for each. So we'll use these identities, these trig equations, to help us solve a few mathematical problems. So I have two examples here, and these two examples revolve around using the sum identity, one for sine and one for cosine. Capital A and capital B are angle measurements, so there's some rotation. For a positive acute angle, A and B, these are these two positive acute angles, acute being less than 90, it's known that the cosine of A is this fraction, 9 over 41, and the tangent of B is 21 over 20. Now, we don't know what these rotations are, what these angles of rotation are, but we don't need to. We can use this identity here to find the sine value of those two angles added together. That's called the sum angle identity. In order to do this, what we're going to do is we're going to build some triangles because we don't know A and B. So we're going to build some triangles that are going to allow us to find those particular side lengths that will also, and then use this formula right here. So we're going to say that the sine of A plus B is this side right here. So this is sine of A times the times the cosine of B times the cosine of B plus cosine A times the sine of B. So what I'm going to do here is I'm going to build a right triangle right here. And I'm going to put this as angle A because it's a positive acute angle, so it's less than 90 here. So rotation is positive. And I know that the cosine of A is 9 over 41. So ca is the adjacent over hypotenuse is 9 over 41. So that means that the adjacent over hypotenuse, 9 over 41, this side is 9, this side is 41. And then what I'm going to do then is I'm going to use this triangle. I'm going to use the Pythagorean theorem here to find this side. This is my opposite side. And I'm going to need the opposite side here because in this angle A, I need to find sine. And sine is SOH, opposite over hypotenuse. So I do need to find this ratio here. And Pythagorean theorem says this, that the hypotenuse squared is equal to the sum of these two sides. Let's call this O. Let's not use O. It looks like a 0. So let's use X. All right, so let's just do some arithmetic here. We'll square it. We'll subtract 9 squared from 41 squared. Take the square root. 40x is 40. So that means this, that this side here is 40. Okay, we're going to do that same thing with angle B. It's a positive acute angle. We're going to call this angle B right here. This was angle A, so this is angle B. And tangent, they say tangent, T-O-A, TOA, is 21 over 20. So the opposite side is 21. This is the opposite side. and the adjacent side is 20, TOA. So this is adjacent side, opposite side, and this is hypotenuse. We need the cosine. If we look at this formula here, it uses the cosine of B. So we're definitely going to need this hypotenuse here. We'll use Pythagorean theorem again here. In this case, I'll say the hypotenuse, let's call that h squared equals the sum of these squared. So use your calculator, square it, take the sum, and then take the square root. We're not going to worry about the positive or negative version because it says it's positive acute, which means this is kind of a quadrant 1 rotation where both these values, sine and cosine, are positive. So use your calculator for this, compute it. This is 29, so I'm just going to put that in my picture here. Now I have all the information I need right here. So if I look at this formula, I need the sine of A. So the sine of A, so SOH, opposite over hypotenuse, so that would be 40 over 41, multiplied by the cos of B. Cos of B. Cos of B is here, so if you need to, help yourself out, is CAH, adjacent over hypotenuse, and then the formula says plus, and let's just keep going here. We need the cos of A, go back to A, cosine adjacent over hypotenuse, 9 over 41 times the sine of B. Go back to here, sine SOH, opposite over hypotenuse, 21 over 29. Now, once we have all those together, we're going to use our calculator. We're going to multiply these two fractions. We're going to get a common denominator. Simplify, 989 over 1189. You can use your calculator there to compute that. Once it gives you a decimal, make sure you put it back in as a simplified fraction in reduced form. Okay, so that's our first example. We'll do the second example. It's slightly different. Notice it wants us to find the cosine of these two unknown angles. It gives us different ratios for each angle. So again, I think it is super important for you to draw pictures here. So we'll call this angle A CAH, C-A-H, adjacent over hypotenuse. And we'll do some math right here. Well, if you know anything, this is a Pythagorean triple, which is a 3, 4, 5 right triangle. You could also do Pythagorean theorem for that. I just noticed that that's a 3, 4, 5 right triangle. 5 squared is 25, minus 16, square root is 3. And then I'm going to build my other triangle here. And my other triangle is with angle B, positive acute angle. So we're drawing it like this. And it says with B, TOA, tangent of B, TOA, is 5 over 12. Opposite is 5. Here's the opposite side. Adjacent is 12. Okay, so here I need to find the hypotenuse. So let's just go hypotenuse squared equals 12 squared plus 5 squared. Use your calculator here. The hypotenuse in this particular problem is going to be 13. Okay, this is super exciting. Now, what do I want? I want the cosine of A plus B. Cosine of A plus B, this is a trig equation that is equal to this. So this is what I'm going to do. I'm going to first just rewrite it, and then I'm just going to use substitution. So I'm going to rewrite. I need the cosine of A. Okay, so here's A, cosine, adjacent over hypotenuse, 4 over 5. So let's write it right below it. Times cosine B. Okay, so let's go to B, cosine, adjacent over hypotenuse. So 12 over 13. Minus, make sure you use the minus sign here, sine A. Let's go back to angle A. Sine of A, SOH, opposite over hypotenuse, 3/5. Lastly, times sine of B. Let's go to angle B, sine opposite over hypotenuse, so 5 over 13. And then strictly, let's just use our calculator. We can type in this fraction times this fraction minus this fraction times this fraction. We could do some mental arithmetic if these numbers are smaller. Multiply 4 and 12, multiply 5 and 13. Same thing here. You're gonna get a common denominator and then just subtract your numerators and then put it in fraction simplified form. Final here, 33 over 65. Done deal. That's called the sum identities. Now the other two identities follows the same logic here, except your formulas are different. So again, remember, a trig identity is an equation that's always true. So if we want you to find the sine of a minus b, we are going to use this right here. So what I'll do here, let's just go like this. Let me just copy this. Let's paste it. And then let's just bring it down here. That's what we want to do. But now, you guys, before we can do that, we need to know, we don't have all the information we need. That's where I draw these triangles here. That's a brutal triangle. So I'll call this one A. I'll call this one B. These are right triangles, not obviously drawn to scale. So A, tangent of A, TOA, T-O-A, opposite, adjacent. Okay, so I'm going to have to find this side right here. This is the hypotenuse. What do? I take hypotenuse squared equals 20 squared plus 21 squared. Use our calculator here. Let's give ourselves just a little room here. 20 squared plus 21 squared. Square root of that is 29. Now, I did not do all that in my head here, you guys. Use your calculator for that. Let's find some of our measurements in angle B, this positive acute angle, sine, which is SOH, opposite over hypotenuse. So opposite hypotenuse, here we're going to take 17 squared equals 15 squared plus, let's call this x squared, whatever this side is right here. We'll subtract 15 squared from 17 squared, and then we'll take the square root at the end. So that side length, after we do that, after we use our calculator to compute that, is 8. Okay, so we have all the information we need. Now let's just put it together. Okay, sine of A. Here's A, sine SOH. So opposite over hypotenuse, 21 over 29. Multiplied by cosine B. Go over here to B, cosine CAH, C-A-H. Adjacent over hypotenuse minus cosine A, CAH, 20 over 29. So of B, opposite over hypotenuse. Let's use our calculator here. When we multiply, so the exciting part then is once we get to this stage here, we can type this into our calculator minus this. Use your calculator to type that in. And we get the fraction negative 132 over 493. You might have to hit math fraction to simplify it. Otherwise, you can multiply the denominators, get a common denominator, that's the 493, multiply the numerators and subtract. One more here. If you feel confident, go ahead, get going on the assignment. If not, just take a peek at one more here. So we got two angles. Let's call this one, we'll build two triangles here. This is angle A, and then we'll call this angle B. So in angle A, what are we given? We're given cosine is 40 over 41. So cosine CA adjacent over hypotenuse, 40 over 41. We're going to do Pythagorean theorem here. We already did that one so far, so I already know that that one's 9. We can kind of use some of our past there. Tangent is 5 over 12, and that's TOA, opposite over adjacent, opposite over adjacent. Pythagorean theorem here, 5 and 12. 5 squared plus 12 squared, 169 squared, or 169 is 13. Okay, so good. We'll build our triangles. We want to use this one right here because we're trying to find the cosine. So let's copy it. Oh, geez. Sorry about that. We're going to copy and paste that. This is what we're going to do. We'll start substituting in here. So really what we want is let's start with, we'll start with this. We'll start with the cosine A, ka, adjacent over hypotenuse. Cosine A, adjacent over hypotenuse. 40 over 41 times cosine B, ka, adjacent over hypotenuse, plus sine soch, opposite over hypotenuse of A. So opposite over hypotenuse, 9 over 41. Sine of B, same thing, SOH, opposite over hypotenuse, 5 over 13. So let's just double check we got things we need here. Everything looks good. Again, let's use our calculator and compute this. We can type it using parentheses like I demonstrated in that first example here. Our denominator is 533, and our numerator in this case is 525. Final answer, that's a fraction in reduced or simplest form.